Hey everyone, this is part 3 of the FEVM Smart Contract as a Deal Client series. We've previously posted a couple of videos showing initial versions of the client contract and some pieces of the deal making workflow. We've now built solutions to cover the gaps I mentioned at the end of my last video, and we'll demo an end-to-end deal with a smart contract on Filecoin. This video has 3 parts. 1, a walkthrough of the deal client contract code and explanation of some of the structures and APIs. 2, an end-to-end deal-making flow using the contract and Boost SP setup on Hyperspace. Lastly, storage provider-focused walkthrough and setup of Boost done by Anton. I'd like to do a quick walkthrough of the deal client contract we will be using for this demo and that you might have already witnessed being used in the ETH Denver demo. To start, we have a deal request struct that will be the input from the contracts client to the make deal proposal function here. Now, the struct is based closely off of the protocol's version of the deal proposal struct and specifies most of the fields needed for deal making. The extra param struct here is primarily needed to specify the location of the car file you want to create a deal for. This is where an SP will be downloading the file from, so it's important this is highly available. Coming back to the make deal proposal function, this is the entry point for a client trying to store data on Filecoin. This function will record the request in the contract state and emit the deal proposal create event, which is being listened to by SPs who are on the other side of the deal making. It basically encodes the request ID and then certain other pieces of metadata, which would be important for SPs to index based on the sort of deals they want to make. Now, once the SP gets the event, they can ask for the deal proposal details using the getDealProposal function, which returns a CBOR encoded bytes of the protocol's version of the deal proposal struct. To give you an example, we have the client and provider fields, which are additional here. The client field is just populated with the contract's own address. The provider field is populated with a dummy address, mainly because we don't know the provider up front. I do want to point out that this will be implementation specific. For example, you may want to hard code a lot of these other events. You may want to do a deal with a specific provider. That's really up to your own implementation. What will not be implementation specific is this event structure and the get deal proposal function signature. This is primarily because these are the two things that what SPs will need to interact with the contract. We will be coming out with an FRC to define these very soon. Okay, coming back to the deal flow, the SP now has your deal request. Once they do their validation on it and they want to make a deal, they will send a publish storage deals message with the deal proposal to the market actor, which will then call back into your contract through the handle Filecoin method. Now, this method is a universal entry point for any EVM-based actor for a call coming from a built-in Filecoin actor, and it specifies the method and the params. It primarily acts as a dispatcher to what we would consider the proper APIs for each of these different methods. Now, publish storage deals has 2 callbacks into the contract: authenticate message and market deal notify. Authenticate message, which is implemented here, is how you would vet the deal proposal coming from the SP and gives you a chance to either accept this deal or reject it. This is followed by the market deal notify, where you can add further validation logic for a final rejection. This basically means the deal proposal has passed all the validation in the storage market actor and is ready to be fully published. This also gives you the deal ID for the final deal, which is then stored on chain and can be used to query your deal state. I also want to quickly go over the add balance and withdraw balance APIs. Now, these are primarily used for paid deals. Add balance is how you fund your escrow in the market actor. Once the deal goes through, this is how your payment is doled out to the SP. Withdraw balance is simply the opposite side of the coin. If you decide you want to cancel a deal request and it hasn't already been published, or if a deal gets terminated by an SP, you can get your funds back using this API. That was a walkthrough of this code. Hope that was helpful. Now I will deploy the contract and demo the end-to-end workflow of making a storage deal with an SP, also giving you guys a behind-the-scenes peek of what occurs on the storage provider side. I'll start off by deploying the contract via Hardhat. Okay, looks like this deployment has gone through. I can take my contract's Ethereum address and have a look in Filefox to make sure the deployment has gone through properly, and looks like it is fine. It's a EVM type actor and just has a single message on it. Great. Now let's actually invoke a call into this contract. I will be using a tool I have to create a deal request structure, which I showed you guys earlier, and call make deal proposal, which is the function to create a deal proposal on the contract. All I need to do is change the contract address here to our new contract. And as you can see, I have populated some of the key fields required for a deal proposal, some of them being the compy, p size, and the location URL where the SP will download this data from. This piece will probably reside in a dApp, which calls into your contract, or yet another contract, which eventually calls into your contract. All right, so here we have a transaction receipt for this call. We will just wait for this to land on chain. While we wait for this, just to remind you, we expect this call to emit an event, which an SP will listen to, get the deal details, and initiate a publish storage deals message. In this demo, I'm acting as that SP and have Boost running right here. Boost is the primary deal-making software used by our storage providers today. And so we'll just wait for the event to be triggered here and the deal-making flow to be triggered on the Boost side here. Cool. So we just got an event from the make deal proposal call we made earlier on. We got this deal proposal, which we received from the network. And here is Boost, just going through its own workflow. Part of it being the deal data transfer, which goes through right here. Checking of the compy to make sure that the compy on the deal proposal and the data actually match together. And in this case, it's sending a deal to the deal publisher. We can further look at the status of this deal here, this is just the Boost UI. And you'll see here that we have one deal ready to publish. So I'm going to click publish now on this. And what this will do is trigger the publish storage deals message to the storage market actor, which subsequently will call into the authenticate message and market deal notify hooks on the client contract, which I showed you guys earlier. So going back to our Boost logs, it shows that the deal has been published successfully. We'll await deal publish confirmation. This means that PSD has gone through successfully. We're just waiting for it to land on chain. We can look at the status of that here. So this is our deal ID, and this is awaiting deal confirmation. Here's our publish message CID. You can have a look at this in Filefox. And now we just need to wait for it to land on chain. Okay, so PSD has now fully landed on chain. As you'll see, this was the PCID, which we included as part of our deal proposal. Our client here is the client contract, and I can show that to you prove that to you by taking this Ethereum address, checking it out in Hyperspace, and if you'll notice, this address is the same as WXFI, is the same as the client address in the deal proposal itself. This provider is my provider ID, and this deal line 85, has been fully published. We can further take a look at this deal in deal list, and it clearly shows my client contract here and the provider address as well. As to what comes next, once this deal publish confirmation has been fully confirmed by Boost, which just maintains a slightly higher threshold than a block explorer like Filefox, it'll pass on the deal to the Lotus miner, which will take this deal and include it as part of a sector to be sealed and stored on the Filecoin chain. Cool. So here we see that the deal published was confirmed by Boost, and it has triggered the add piece API on the Lotus miner, which will add this piece into a sector which is being sealed by the Lotus miner. We can actually check that out in the Boost UI right here itself. It shows you that sector ID 3103 is what sector this deal will be part of, and I can further prove that to you by looking at the status of this specific sector, and you see that our deal ID 985 is part of this sector. Right now, the sector is simply waiting for more deals to come in so that it can more efficiently pack the sector, after which it will be sent over to basically get fully sealed. And once the sector is fully onboarded, your data is now stored on Filecoin. Well, that was it for our end-to-end demo for the deal-making workflow with the client contract. I hope this demo helps, and we're super excited to see what the community builds with it. Please follow us on Filecoin Slack on the deal client contract channel.
Hey everyone, today I'm going to show you how to make due proposals with the FEVM and what the flow looks like for storage providers who are running Boost. So let's get started. I'm going to be showing the current setup on a local DevNet. So let's spin a local DevNet up. What I just did is I started a Lotus miner and a Lotus daemon with the version 1.20, the latest stable Lotus version, as well as Boost built from the main branch. We'll be releasing Boost soon, which will have support for FEVM contract deals. So we have to wait a little bit for all this to start up. The contract deals that I'm going to show you here are going to be interacting with a client contract built from the Filecoin project FEVM hardhat kit. This is basically a reference implementation that implements the current draft FRC for dual clients. So let's see if Boost is up and running. Right, so we have a new DevNet running locally with Boost and Lotus 120. So now we have a contract that we can interact with, and we can make due proposals on as a client, as a developer on a given Filecoin network. Boost will automatically, by default, detect all due proposals made on chain, and the Boost operator is free to also edit the whitelist. So let's go to Boost and fix our settings. The first thing I'm gonna do is I'm gonna reduce the storage ask price to 0 because we don't want to be locking funds in escrow. So I'm just gonna set them to 0. And the next thing I'm going to do is I need to edit the Boost config to allow for contract deals to be processed. By default, it's not enabled. So let's do that. Basically on the DevNet, we can find the Boost repo in the data Boost directory, and we edit the config toml, and we're looking for contract deals. There are three fields here. The first one is basically whether we should enable the contract deal monitor, and I'm going to set this to true. The second one is if we want to add any allow list, basically whether we want to be taking deals from the whole network or we just want to be taking deals from specific client contracts. And the third field, currently set to the 0 address, is necessary in case in the future contracts add KYC to their addresses and check who is allowed to actually take on some of their deals. So I'm basically modifying this right now to just enable for contract deals. The next thing that we need to do is we need to basically restart Boost because we modified the config YAML. So I'm just going to say docker remove Boost, and I'm gonna fire it back up. So now if we check the logs for Boost, we will see that the contract deals monitor has been started because we just enabled into the config YAML. We can also see that the contract deals monitor is making a subscription on this Ethereum topic. So basically that's according to the FRC for the deal client, the draft FRC. This topic basically is monitoring for the deal proposal created, which currently has a bit more fields than what's written here in the FIP discussion. So let's make a deal proposal and see if Boost detects it. So we have Boost running here. You can make a deal proposal by interacting with the client contract, that we just deployed to this address 0x13, etc. This can be done with any Ethereum tooling. For today's purposes, I've built my own tooling. I call it the Daos tool, and we are just going to interact with that contract. So basically, we specify the contract address, we specify the chain, and I have already prepared the data that I want to make a deal proposal with. I've included the comp for the data, the P size, the car size, as well as start epoch, storage price, payload CID, everything that you need to specify when making a deal on Filecoin. In terms of when the deal should be active on chain, where the storage provider should fetch the data from, what's the digest for the data, etc. Basically, I've just made a screenshot and I've packaged it as a car file. So let's just do a curl request on that HTTP endpoint to make sure that it works fine. We can see that we received 200 OK with the content length, so it looks like it's up and running. So let's make a deal proposal. And we just fire the transaction. As soon as the transaction is mined, we should see that Boost automatically detects the deal proposal, and it came up in the user interface. It's for 230 kilobyte deal. The transfer has been queued. We've already downloaded the data, so we can see that we get all the parameters for the deal proposal. It passes through basic validation. Then Boost makes an HTTP request and downloads the data. And now we just need to publish that data, publish that deal. So basically we publish the deal, and then we need to await publish confirmation. That's basically waiting for 4 or 5 epochs on chain, just to make sure that there are like no reorgs, and we're going to get a consistent identifier for the deal. As soon as this stage is passed, we are basically passing the deal to the sealer subsystem, and we can now retrieve this data from that particular storage provider. And we can see that the data has been passed to the sealer. The next stage is for the sealer to go through all of its stages, seal the sector and get it into proving state, at which point every 24 hours we'll be submitting zero knowledge proofs on chain that this storage provider still keeps the data locally. So let's try to download this data through the payload CID. So we know the payload CID of our data. and I'm just going to attach to the devnet. So let's stop looking at the logs and let's exec into boost and try to retrieve this data. We have the boost retrieve command where you can retrieve data. So I'm going to specify the provider address and I'm going to specify the payload CID. But we first need to initialize the boost client. We're lacking the full node environment variable, so what we can do is we can say Lotus auth API info with permissions. We want to export that endpoint to Lotus. We want to initialize the boost client, and then we can retrieve the data. So basically, boost retrieve needs to have access to Lotus full node so that it can find out what's the actual address for the provider that I'm specifying here. And then on chain, we get the data for the provider and we make, in this case, a libp2p request to fetch this payload. So if we list, we can see that we just downloaded the data in this file. I'm just going to move it into a folder that's mapped on my host machine, and let's go with file.png. And now I'm going to go to the host machine and we can see that we have it here, file.png. And if we open it up, we can see that it's a screenshot that I took a few days ago. So basically that's in general what the flow is to make a due proposal with a client following the FRC standard and have an SP monitor the chain and download data and make basically deals with clients on chain. You can read the Boost docs on the Boost website, boost.filecoin.io. We already have documentation within the experimental features like FEVM contract deals. As an SP, all you need to do is you need to enable contract deals in your config toml. So that's all from my side. Thank you.